This is a video on the interval of convergence. The question states, find the interval of convergence of the power series, summation from n equals 0 to infinity, of -1 to the n times x plus 3 to the n divided by n plus 4 times 5 to the n. So the test to use when we're working with a power series is the ratio test. And remember, the ratio test says I take the limit as n goes to infinity of a sub n plus 1 over a sub n. A sub n plus 1, that means everywhere I see an n, I just plug in an n plus 1. And a sub n means I just write down the terms as they are. So this is a mess, but we can simplify things greatly by using algebra. Here we're dividing two fractions, so I'm going to multiply by the reciprocal. Next, I'm going to look at the factors and group them together. So notice I have a -1 to a power on the top and bottom. I have a polynomial n plus 4 and an n plus 5. I have a power of x plus 3 on the top and bottom, and I have a power of 5 on the top and bottom. So I'm going to regroup that as the limit as n goes to infinity of -1 to the n plus 1 over -1 to the n times n plus 4 over n plus 5 times x plus 3 to the n plus 1 over x plus 3 to the n times 5 to the n over 5 to the n plus 1. And I'm going to tackle each of these individually. So first thing, when we're taking absolute values, -1 to a power is always just 1. So these actually go away. And the -1 to the n plus 1 over -1 to the n in absolute value is just 1, and it disappears. For the rest, I can have n plus 4 over n plus 5, and I'll write that as a separate limit. X plus 3 to the n plus 1 over x plus 3 to the n, I can use a rule of exponents, and that says that I can subtract n plus 1 minus n, which is just 1, and I get x plus 3 to the 1, or just x plus 3. Similarly, for 5 to the n over 5 to the n plus 1, I use the rules of exponents, and that says I subtract n plus 1 minus n, and that's just 1, and I just get 1/5. So this first limit, the limit as n goes to infinity of n plus 4 over n plus 5, that goes to infinity over infinity, and I can invoke L'Hopital's rule. So the derivative of n plus 4 is 1. The derivative of n plus 5 is also 1. 1 over 1 is 1, so that term just goes away. And the other two, there aren't any n's involved in x plus 3 or 1 over 5, so the limits go away. And what I'm left with is just x plus 3 over 5 in absolute values. Now remember, I'm in the middle of the ratio test, and the ratio test tells us that if this limit in absolute values is less than 1, then the series converges. So let's set this to be less than 1. I get the absolute value of x plus 3 over 5 is less than 1, and do a little more algebra. I multiply by 5 on both sides, and I get the absolute value of x plus 3 is less than 5. And recall, when we have an absolute value inequality, we could break this up into an AND statement of two inequalities. And I can write this as x plus 3 is less than 5, and x plus 3 is greater than -5. And now it's very simple. I just subtract 3 from both sides, and what I get is that x equals -8, or x equals 2. So notice that 5 minus 3 is our 2, and -5 minus 3 is our -8. Those are our two endpoints. The radius of convergence, that comes from this x plus 3 in absolute values is less than 5. When we've isolated an x plus or minus a number in absolute values is less than a number, then that right-hand side is the radius of convergence. Okay, so I'm almost done. I now have my radius of convergence. I have my endpoints. So I know the series converges between -8 and 2. What I don't know yet is what happens at x equals -8 and what happens at x equals 2. So what I do now is just plug in -8 in for x in the original series. And what I get is the summation from n equals 0 to infinity of -1 to the n times -8 plus 3 to the n over n plus 4 times 5 to the n. Well, -8 plus 3, that's just -5. And -1 times -5, that's equal to 5. So this simplifies to the summation from 0 to infinity of 5 to the n over n plus 4 times 5 to the n. And the 5 to the n's cancel, and I'm left with the summation of 1 over n plus 4. I can use the limit comparison test by comparing with the harmonic series the summation of 1 over n. And the summation of 1 over n diverges. So I'm going to let you work out the details. But since 1 over n in summation diverges, and when we take a limit of 1 over n plus 4 over 1 over n, that goes to 1, which is not 0 or infinity, we can say by the limit comparison test, our series, the summation of 1 over n plus 4, diverges. So that gives us the left endpoint diverges. Now let's work on the right endpoint, x equals 2. So I plug in x equals 2 in for x, and I get -1 to the n times 2 plus 3 to the n over n plus 4 times 5 to the n. Well, 2 plus 3 to the n is 5 to the n, and the 5 to the n's cancel. And I'm left with the alternating series, -1 to the n over n plus 4. So notice that 1 over n plus 4 is a decreasing sequence, and it goes to 0. So by the alternating series test, our series, a summation from n equals 0 to infinity of -1 to the n over n plus 4, converges. So that tells us that when x equals 2, the original series converges. So now I have everything I need to state my conclusion. I know my radius of convergence is 5. I know my interval goes from -8 to 2, and I know that it diverges at -8 and converges at 2. So I can say that the interval of convergence is the interval from -8 to 2, not including -8 because it diverges at -8, but including 2 because it converges at x equals 2. And I'm done with the problem.